Hi guys, in this video we're going to go through a 7-mark exam question about using C plus IS, but it's actually going to be in a geometric series scenario. So C plus IS, what that means is, well, you multiply I onto each of the S components and add the equation for C onto it. So we'd have cos theta plus I sine theta for the first term of the sequence. Let's just carry on and write out a few of the terms of the sequence. And then we'd add on to that what we get when we do this expression of C plus I lots of this expression of C. So we have cos of theta plus 2 pi over n, and then plus I multiplied by the sine component of theta plus 2 pi over n. And we just go on from there, so on and so forth, again and again. To find C plus IS, well, let's think about it like this. The sum of n amount of terms in a geometric sequence is going to be equal to A multiplied by 1 minus r to the power of n all over 1 minus r. Now, why do I mention a geometric sequence? Well, if we expand this out, we can actually write this expression here as e to the power of I theta. We can write the next expression as e to the power of I, and then in brackets, theta plus 2 pi over n, so on and so forth, again and again. And then we think to ourselves, okay, well, how do I go from the first term to that second term? Well, let's think about it. Let's expand this power out. We'll get e to the power of I theta plus 2 pi I over n. And if we think about it, that can be split up into the first term, e to the power of I theta, and you multiply onto that, e to the power of 2 pi I over n. Once you've established this, we can then state that this is actually the common ratio. It's what you multiply by to get to the next term of this sequence, C plus IS. So we have that the common ratio is e to the power of 2 pi I all over n. I'm going to zoom out a little bit. We also know the first term of the sequence is just e to the power of I theta. So let's actually substitute into that expression. That will give you e to the power of I theta, and then in brackets we have so one of my students said the way I write theta annoys them, but hopefully it doesn't annoy you guys too much. But you then can write 1 minus the common ratio, which is e to the power of 2 pi I over n, all to the power of n. That doesn't look too clean. Close brackets, all divided by 1 minus the common ratio that we just found, e to the 2 pi I over n. Now, how can we show that the sum of this, the sum of n amount of terms, is actually just going to be 0? Because that would then show that C and S is actually just 0. Well, if we think about it, whenever there's power inside and outside the bracket, we can multiply them together. The over n and the multiplication by n onto the numerator would cancel out. And so we'd be left with the same expression outside of the bracket, and then inside of the bracket, 1 minus e to the power of just 2 pi I. The denominator, we'll just keep it as it is right now, and I'll show you guys why. 2 pi I over n. Now here is where we can use de Moivre's theorem. Before we went from this cos theta plus I sine theta into e to the I theta, but if we go the opposite way around, we can say that e to the 2 pi I, well, that's just what you'd get when you replace theta with 2 pi and this theta with 2 pi as well, because that's what we've done comparing e to the 2 pi I to e to the I theta. So it'll be cos of 2 pi plus I sine of 2 pi. Now cos of 2 pi, that's just equal to 1. I times 0 is just 0. So that means that this expression here would just become 1. So the numerator becomes e to the power of I theta. And then in brackets, we have 1 take away 1. Well, if the numerator is equal to 0, that means that this whole fraction will equal 0, because 0 divided by any number is 0. And so we can conclude that the sum of n amount of terms of the sequence is 0, meaning C plus IS would also equal 0. If that's the case, then that means the real part is equal to 0 and the imaginary part is equal to 0, if you imagine this as 0i as well. And that proves that C is equal to 0 and S is equal to 0. And that's it. That's everything for this pretty difficult question, combining geometric series and complex and imaginary numbers. Be sure to leave a like if this video helped and subscribe. I'd appreciate a lot. Thanks for watching. Have a nice rest of your day. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.